Welcome to MathGPT. Today we're going to talk about fields in physics. A field in physics is a physical quantity that has a value defined at every point in space and time. Fields are used to describe how a physical property is distributed throughout a region, even in the absence of direct contact. Now, let's talk about the two main types of fields in physics. We have scalar fields and vector fields. A scalar field assigns a single value or a number to every point in space. For example, temperature is a scalar field. At each point in a room, there's a specific temperature value. On the other hand, a vector field assigns a vector, which has both magnitude and direction, to every point in space. Some examples of vector fields include the electric field, magnetic field, and gravitational field. Why do we use fields in physics? First, fields help us explain action at a distance. How objects can exert forces on each other without touching. For example, the Earth orbits the Sun due to the Sun's gravitational field, even though they're not in direct contact. Second, fields help us visualize and calculate the influence that a source like a mass, charge, or magnet has on the space around it and on other objects within that space. Let's look at some specific examples of fields in physics. First, the gravitational field. It's represented by the vector g and describes the force per unit mass exerted on any object due to gravity. At a point in space, g equals F sub g divided by mass m. Another important example is the electric field. It's represented by the vector E and describes the force per unit charge exerted by electric sources. At a point in space, E equals F divided by charge q. The magnetic field, represented by the vector B, describes the force per unit charge per unit velocity on moving charged particles. Let's summarize what we've learned about fields in physics. A field is a way to assign a value, which can be a number or a vector, to every point in space, letting us describe how physical effects are spread out and felt throughout the universe, even where there's no matter or direct contact. Here's a summary table showing different types of fields, examples, and what they describe. In conclusion, fields are a fundamental concept in physics that help us understand how forces and energies are distributed in space. Whether it's gravity, electricity, magnetism, or even quantum mechanics, the concept of fields provides us with a powerful framework to describe and understand the physical world around us. Thank you for watching.